Hello there class, we are discussing Spark, another core component of the Apache Hadoop ecosystem. In the previous video, we have knew that Spark can work directly with Metastore, that is a major component of Hive subsystem. We already knew that before starting Spark, the system connects the Spark SQL to Metastore, and we can see in the logs right here. And we know that this is a HDFS terminal that we have started Spark SQL, and even we have run the command show tables to find out which tables or the schemas that currently existing or available in the Metastore. Okay, and the results show that there are two schemas or external tables that are currently existing in the Metastore. That is weblog_3 and weblog_5. And we already knew that. We have seen the same thing when we run the command line in the Hive environment, is right? Okay, let's get back to the terminal window that we are running the Hive there. Okay, here is the terminal that we are running Hive, is right? And we have the Hive prompt right here. And we also run this command to show the tables that are currently existing in the Metastore. Okay, now let's run some queries on this data set or on this table again in Hive environment. Alright, let's get back to the terminal where we are running Hive, is right? And this is the Hive environment. And we already knew that we have run this command to list the tables, the schemas that currently are available in the Metastore. And the same thing, we already see two schemas or two external tables right here. Now, in this terminal, I have run this command to perform simple queries on the data of the table weblogs_3. And we already knew that is right. This command line will display the first row of the table, and this one will display the contents of the first 3 rows of this schema weblogs_3. Okay, let's run another command line in the Hive environment, and then we can relay all these things to the Spark SQL environment. Okay. Okay, let's run this command. Yes, we saw it before, it's right. Now, but here not on the weblogs_3 we run it. This one is well-defined queries. We run on a well-defined schema, and it is weblog_5. Okay, let's run it. Yes, it takes some time to run through or to finish the queries, because this dataset is not very big, but it is big. Yes. Okay, now the result of the query show here the top 5 users. Yes, I mean the top 5 active users that we can find in the dataset, is right. And let's say again, all these command lines are run in the Hive environment. And here is the Hive prompt. Let's do or let's perform these queries in Spark SQL to see how it goes. Is right. Okay. Okay, let's get back to the terminal where we are running Spark SQL API. Yes, I will rerun the command lines that we just did in Hive environment to see how it goes. Okay, first let's run this simple query. Yes, we are very familiar with this one, is right? Let's press enter. Yes. What do we see here? Okay. We have seen it before, is right? These are the contents of the first row or the first rows of the schema. Actually, these are the names of the variables or attributes or the column names of the table. The same when we run this command line in Hive environment, is right? Okay, let's run another command. Yes, instead of one we say that first 3 rows, exactly the same thing. Let's look at here. Yes, let's look at here. We see it similar, the same thing. These are the contents of the first 3 rows of the schema. And then both these command lines we run on the schema web logs underscore 3, is right. Now let's run a command line on web log underscore 5. Okay, let's run this command. Yes, we've seen it before. Let's press enter. Yes. Okay, now what it is? The same thing, is right? Yes. So we have run the command lines, the same one, in both environment, Hive and Spark. Okay. And remember that in these two environments, both environment depends on metastore component of the Hive subsystem to understand the data structure so that it can run or perform the queries on the data. Okay. Let's get deeper into what is done underlying the surface. Okay. Okay, let's get back to this picture. We have discussed this diagram before. It describes how Hive collaborates with MapReduce and HDFS to run the queries on data. And we see here the query starts from here. And then the main components of Hive is the execution engine. And here is the metastore. And then this part is for MapReduce and HDFS. We see that the Hive server right here, that is the execution engine, it will depend on metastore to understand the structure, the SQL structure of the data. And then it will send the request to run queries, jobs on data to MapReduce. The MapReduce will work on the job, and you see here they split it into smaller tasks, and then when they get the result, they will finish the review phase, and by that way we will get the result. It means combine all the result to get one and deliver back to the Hive right here. Okay. So with this diagram, we see the process how Hive working with MapReduce and HDFS to finish a job. Okay. And with this diagram that describes the process how Hive working with MapReduce and HDFS show us that there are a lot of communication, many steps working among these three entities to complete a queries on data. And such many steps, a lot of communication among these three entities will hurt the performance of the system. It means it slows down the system. It takes more time to finish the queries. Okay. Now, let's look back at what we have done when we run a query in Hive environment. And here we are back at the SSH terminal window in which we currently running command lines in the Hive environment. And let's see how we run this query. Okay. The Hive environment, the Hive MapReduce and HDFS finish this command line or the queries on the data, and it costs or it takes about 17.5 seconds. It is right here. Okay. To finish this query, to provide the results for this query, HDFS, MapReduce, and Hive needs nearly 70.5 seconds. Okay. Now, let's talk about the Spark, or more accurately, the Spark SQL, how it runs a similar command line or similar query. Okay, now we get back to this picture, and we already knew that the Spark SQL can work directly with Metastore. Spark SQL depends on Metastore to understand the SQL structure of data the same as Hive does. Okay. The difference is Hive have to work with MapReduce to finish the query. Spark SQL does it by itself. Yes, it brings in the data into its system and it runs by itself. And by that, it avoids a lot of communication, a lot of collaboration, because such a kind costs times, yes, and hurt the performance. And we expect that Spark SQL can run the same query faster. Okay, let's look at what we did with Spark SQL. Okay, here we get back to the SSH terminal window in which we have run the queries and using Spark SQL. Okay, and here it is we can confirm that it is exactly the same as query we did with Hive and MapReduce environment. Also, this query is run on the same dataset, and its schema is stored in the same Metastore. Okay. The only difference is we use Spark SQL to run this query. So, is there any difference? Okay, let's look it up this one. Yes. How much time does it take Spark SQL to complete this query? It is right here, 4.8 seconds. Yes. To complete the same queries on the same dataset, on the same data as Hive and MapReduce did. However, it takes only 1/4 of the time that Hive and MapReduce needs. And you see, and you remember that Hive and MapReduce needs about 17.8 seconds, 17.5 seconds to finish the job. Here, Spark SQL needs only 4.8. It means that the Hive and MapReduce need nearly 4 times, yes, 4 times longer to finish the same query. And by that way, with such a kind of result, and the performance that we can see here, we can say that clearly Spark SQL can run the same job, can perform the same query on the same data much faster than Hive and MapReduce. Okay, let's summarize what we have done and seen and observed. Okay, first, Spark SQL, okay, can be set up in the Apache Hadoop ecosystem to process data in HDFS. Both Hive and Spark SQL use Hive meta store to understand the structure of the data. And as we have seen, both Hive and Spark can run the queries in the same cluster. Okay? But the main difference between Spark and Hive MapReduce is what? Hive MapReduce converts SQL query into Hadoop MapReduce jobs that are run by Hadoop MapReduce to get the query result. For Spark, it processes the data with in-memory computation and transformation by itself. It does not have to convert SQL query into Hadoop MapReduce job. It does not need Hadoop MapReduce to run the query job. It runs the query by itself. And that iteration, it can finish the job much faster. And we now get back to these logos. And Spark said that it is lightning fast cluster computing. Now, at least we have something or some idea to support that is right. Okay. And it's true. And that's all for this video.